So as I walk around, I see some of you are trying to figure it out by using the graphing calculator, and you're coming up with a 0. That's good. But what we're noticing is that we already identified that this must have a 0, because the endpoint behavior, this graph, we know, will fall to the left and rise to the right. So the only way something is happening between here, there is a 0. Well, all that it tells me is that because I didn't get 0 for either one of them or both, it's telling me that the 0 is not a rational number. It is not a rational number. So my conclusion here, the 0, or from over here, we can say the 0 is not a rational number. It is not a rational number. Okay? So there will be cases where you will have a polynomial and the 0 wouldn't be a rational number. And then we'll have to come up with some other way to possibly find those zeros. Okay? We've talked a little bit about that, where we said we can narrow down the interval in which the 0 is. So we will come back to that. But in this example, there is no rational 0. So let's look at another example. Yeah. Let's look at the polynomial g of x is equal to x cubed minus 7x minus 6. So example, g of x is equal to x cubed, I said, minus 7x minus 6. And we are looking to find, so we want to find the zeros. Okay? Well, we don't know how to factor the cubic, but if we can write it as a product of a quadratic and some other factor, then I could probably, or I will be able to find the zeros of a quadratic. So I'm going to use the rational zeros. Yes. So that's P over Q, where it's the factors of 6 over the factors of 1. Okay? So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And the factors of 1 are just plus or minus 1. So what are all my possibilities here? Well, we could have a positive 1 over a positive 1. Or we can have a negative 1 over a positive 1. Or we could have a negative 1 over a negative 1. Okay? So no matter what your outcome here is, you either will get either a plus 1 or a minus 1. Okay? So this will give me a positive 1. This will give me a negative 1. Okay? So the outcome here would be either a 1 or a negative 1. And then we move down to the next scenario. We have a positive 2 over 1, or we have a positive 2 over a negative 1. Or we have a negative 2 over 1, or we have a negative 2 over negative 2 over 1, or a negative 2 over a negative 1. So once again, the outcomes here are -2 or +2 and a -2. So if you keep doing that, we'll have to say, what are the possibilities of the 3? Well, it will be a +3 over a +1, or a +3 over a -1, right? It's a plus or minus, so we're only keeping the positive, and we're going fluctuating between the minus and the positive. Or we can have a -3 over a +1, or we can have a -3 over a -1. So here we have either a +3 or a -3. And the same thing, we'll notice that for 6, we'll have a +6 over 1, or we'll have a +6 over a -1, or we'll have a -6 over a +1, or we'll have a -6 over a -1, so that brings us with 6 or -6. Well, let's see, let's just check, is 1 a factor? What is g of 1? Well, that becomes 1 cubed minus 7 times 1 minus 6, which is equivalent to 1 minus 7 minus 6, and that does not equal to 0, right? Not equal to 0. Well, let's put it here. So our conclusion is 1 is not a 0. So this one here is out. Okay? What about g of -1? Well, that becomes -1 cubed minus 7 times a -1 minus 6. So this becomes -1. This becomes +7 minus 6. This becomes 6 minus 6, which is equal to 0. G of 1 is equal to 0. So that tells me that x, g of -1 equals 0. This implies that x equal -1 is a 0. If x equal -1 is a 0, this tells us that x plus 1 is a factor. Okay? So if x plus 1 is a factor, okay, if x plus 1 is a factor, it means that g of x is the same as x plus 1 times some quadratic. And we could find what that quadratic is by using synthetic division or long division. Okay? Because if you multiply a quadratic times a linear, you're going to get a cubic. And we saw earlier that if we know a factor or we know a 0, we know what the quadratic will be. Okay? And we can do that. So if we look at what is this quadratic? Well, we can use synthetic division. Okay? So if we say that -1 is a 0, and we bring down the coefficients, now notice there's a missing term. So we have a 1, a 0x squared term, a -7, and a -6. So this becomes a 1. -1 times 1 is -1. If you add these two, you get -1. -1 times -1 is +1. If you add these, you get -6. -1 times -6 is +6, and it's a 0. So once again, that 0 implies that -1 is a 0. So this tells me my quadratic. This is my quadratic. Okay? That's my quadratic that I'm looking at. So this implies that we have, since this is a cubic, the degree will decrease. So we have 1x squared minus 1x minus 6. And this is the quadratic that will go in here. So g of x, which is x cubed minus 7x minus 6, can be written as x plus 1 times x squared minus x minus 6. And now clearly this is a quadratic. We could either factor this, or we could find the zeros by the quadratic formula. Well, I think this can be factored. So if we have x minus 3 times x plus 2 can be factored. And here we have x plus 1. So what are the zeros? Well, we can say the zeros here are, the zeros are now x plus 1 equals 0, or x minus 3 equals 0, or x plus 2 equals 0. So x is equal to negative 1, or x is equal to 3, or x is equal to negative 2. Meaning that if you look at the graph of this polynomial, it will cross or touch the x-axis at negative 1, positive 3, and negative 2. Okay? So we can try some examples, some more examples. Now keep in mind, if the zeros were irrational, we wouldn't have got them. Okay? So these are the rational zeros.